Hi students. So in the last lecture you have learned what is Bison and how to use it using a simple example. Okay, so today we just like to extend it with a realistic example, but the example is not so useful today because we have very uh, limited lexical analyzer. So we'll extend it further with a full-fledged lexical analyzer with Bison. Okay, so let me just share the today's material, today's handout. So let me just enlarge this a little bit and switch the screen to the handout today. So today's topic is using Bison. As you know, the Bison is a descendant of YAC, which stands for yet another compiler. So it adopts the extension .y, which was used in YAC. So for Bison, you can use .y file as input. Also, it has an option -y, which means that -y, which means that support the compatibility to YAC. So for instance, you may use the following file, simple.y for Bison input. Okay, so here you can see several declarations. So similar to Lex input, you can see that the sections is subdivided into three parts. This part is a declaration part, and this part is the sense of it. It is a pattern action part. And the third part is like this. It is for auxiliary procedure part. Auxiliary procedure. So in these three sections is separated, delimited by %, just like in Lex input. And declaration part may contain C declarations. So as you know, this is called C declarations. And C declarations is copied to the to your C file. So it is directly copied to your C file. And it may contain another declaration which is used, the token declaration. So you can see the token declaration here. So this declaration means num is a token, num is a value token. So you may see that this is a terminal in your grammar rule. And another terminal is maybe you may use any character, any single character may be used as a terminal. So that should be quoted. So any single character can be used as a terminal. So here you have two terminals in the grammar rule. So the pattern action part is containing the grammar rule. So the grammar rule is specified here. So the grammar rule implies that it is much like exp produce exp plus num, where num and plus are the tokens, or it can be a terminal num. Okay, so this grammar rule may be represented this, and for each rule, you know that it consists of two rules, the first rule and the second rule. Each rule is attached with the action. So you have two actions. The first action is printing E arrow E plus N, and second action is printing E arrow N. So you know that these two blocks are the actions, okay? And you also in the third section, you may see the auxiliary procedure. So in the auxiliary procedure, you're calling YI parse. So actually the pattern action part is encoded as YI parse. So that is the role of Bison, such as it is similar that your legs or flex is producing YY legs. Okay, so similarly, your Bison will produce YY parse. Okay, and YY error is used for the error handling. It is just to use string message to the standard error. And YYLX is generally adopted by Flex, but today you are just make it a simple lexical analyzer. It is reading a character. And if it is a new line, then terminate the current input. 0 means end of input. End of input. And if it is not, you examine it, the character is a digit, then returning token none. For other cases, it is returning itself as is. So I expect that this is plus or something. Okay. So note that the simple lexical analyzer is built in as an auxiliary procedure in the previous code. It treats the character as a lexical token and returns the end of input once a new line is read. Okay, so let's switch the screen to your MC's screen. So before that, let's take a look of Makefile. So it is very similar to the flex case. So since Bison accepts .o flag, the flag is an option for specifying its output file. So which means that if you are using not -o, then the flag, the simple.c is the output file. This is output file. And as you know, simple.y is the input file. So using a Makefile macro, you may substitute this for simple.y. And you may substitute this for the output file. So rather than using this command line, you may use Bison -o with the target, which is simple.c, and Bison -o with a target and $less than, which is the source, simple.y. Okay, so this is very similar that simple.c is the input file, and then simple is the output file. Okay, so with this setting, you can just switch to the screen of to MSys. Where is my MSys? So I have to start this MSys. here. So you may type the simple.y. So it has the same contents to the simple.y in your handout. So you may execute Bison with dy as simple.y. Okay, so it will produce lex y.tab.c. So can you see that y.tab.c is just created with y.tab.h, which is declaring the definition files macros for the token. So you can compile y.tab.c and you can execute it a.exe, and you may type 1 is a valid expression. Okay, so you may try a.exe. 1 plus 2 is also a valid expression. So let me just think about that. This 2 is called the right parse. You know that this one and this one is called right parse. Okay, which means that if you have 1, it is treated as num, and num is reduced to your exp. Okay, so you are building a tree with this right parse. So how about this? Your input is 1, which is num, plus 2, which is another num. Then this one should be applied first to reduce to expression. And then this one, which means that e plus n is reduced into another another expression. Okay, so from the right parse, you may construct this parse tree. Okay, any questions up to here? Did you get it? And Arugyo, you should.
No, I don't have.
Yeah,
No.
understood everything.
Okay, good. So it is understandable.
Yes.
Okay, so
Yes.
I'll talk about another example. I think about another example. So a.exe, so 1 plus 2 plus 3. Okay, so it can be explained similarly. 1 is a number. Your input is 1 plus another number 2 plus another number 3. Okay, and this is reduced to e expression, and e plus n is reduced another expression, and e plus n is reduced another expression to build this parse tree. Okay, so this sequence of production rules is the production rules used in your shift reduce parsing. So in your shift reduce parsing method, you can build up this parse tree according to the right parse. So this sequence of production rules is called right parse. which means that it is the number of production rules in rightmost derivation in reverse. Okay? So the
Yes.
rightmost derivation in reverse can be explained like this. If you really want to derive this from your expression, you may think the rightmost derivation, exp plus num, okay? And you know that this is another expression, exp plus num is, and this one is num plus num plus num. So you know that this is truly rightmost derivation. Naran Chachrat, you may be helped by your TA. So, can you help Naran Chachrat? He is in this room. He'll help you. But for now, you just focus on the lecture today because it is related to the today's problem. Okay. Okay. So let's go back to the today's problem in your handout. If you don't have any question. So programming lab 8, this is somewhat simple. Today's problem is simple. Okay. You may extend the language to accept additional operators for minus for subtraction, times for multiplication, slash for division. You should start with the following grammar. Expression is expression plus term, expression minus term, or term. Term may be term times f, term divide f, or f. And f means a factor. It can be a number. So write a program, the Bison, reading the expression from the standard input and generating the right parse to the standard output. The production rule of the right parse should print in the following form: left-hand side arrow, right-hand side, where left-hand side denotes a single character for the left-hand side of a production rule, and the right-hand side denotes the string for the right-hand side of it. So the right-hand side does not contain any spaces. For a token num, you just use n rather than num. Given the following input expression, for example, your program should print the following output. So you have to understand why this is produced. Okay, so let me just use an example. So you may just take a look of the handout with this. And from the handout, you can take a look of the grammar rule. As you know, E is the start symbol. So from rightmost derivation, you have to use E plus T at first. And from now on, it is always rightmost derivation. Rightmost without the subscript. And then your T should be produced, substitute by T times F. Since it is a rightmost derivation, you have to derive this. Okay? You know that this is a rightmost derivation. So your F should be substituted by none. So in this case, num is 3. Okay, so Riemann's derivation. So since this is terminal, your next target is this, E plus F num, and then F produces to another num times num. So as you know, this num is 2, this num is 3. And then you have only single non-terminal, then this will produce t plus num times num. And for t, it will produce f plus num times num. And f will produce num plus num times num. Okay, so you may wonder that which production rule is used here. So f arrow number is used here, and t arrow f is used in this step, and e arrow t is used in this step, and f num is used in this step, and tf is used in this step, and f num is also used in this step, and t times f is used in this step, and e plus t is used in this step. Okay, so from your derivation step, you have used this sequence of production rules. Okay, but your right parse starts from your input, so your right parse should read this sequence in reverse. Okay, so that means this is the right parse. Okay, so your program should produce a right parse given a valid input. Okay, so do you understand what is the goal of today's topic, today's problem?
Yes.
Good. Good. So
Yes.
how about are you on board?
Yes.
Okay, good. So based on this experiment, you just write a report with references, assignment 9. You can write a report in Korean. Your report should contain the following material because you propose of this report in your Word and your Bison info file with the explanations and what you have learned in this laboratory. And your program should read from standard input. Input consists of a single line containing an arithmetic expression. And as you know, there's no spaces included except a new line. Only the 4 operators are allowed in the expression, and only single digits are allowed for the operands, since you have to reuse the previous YY lex. No spaces included in the input expression. The program should print the output to the standard output. Output should be the right parse of the input expression. It consists of a sequence of production rules. A production rule should be printed in the form of described above, which is left-hand side space minus greater than as an arrow space right-hand side, and there's no other spaces in your output. So 1, you just check it. This should be your output. 2 times 3, you just check it. this should be your output. Okay, and more complex case is the previous one. Okay, do you have any questions?
No.
No.
Then you have 45 minutes to go, and I have to check for lay students. And before that, Gancharot Naran Chachrat will be helped by your TA. Okay. So should I assign you, Gancharot? Should I assign you to a conference room? Okay, good. So I'll check for lay students. Gancharon is late today. Okay, so you're late. Bimbazab Anousin? No, attended. Okay.
Hello, here. No.
You attended?
Hello.
Okay,
Yes,
so
I am.
you're late today. Son of Damir?
Yes.
Okay, you're late today. Hatessen? Okay, so Hatessen is not attended. So I'll just invite Gancharon to your conference room. So Gancharon, please attend the conference room.
Professor, I have a question about the Bison function definition.
Mm-hmm.
So if we look at the example code you gave us, we are like, defining int yylex and void error at like on top of the file as well.
It is just a declaration.
Yeah, sorry, declaration.
Yeah, that is not a definition.
Yeah, so I was wondering, like, because these functions, like, we didn't declare it in Flex, but we are declaring it for Bison. So I was wondering, like, what was the reason for that?
Because simply, you know that these lines 9 to 11 will be translated to YY parse. Okay, and your YY parse is assuming that these two files are these two functions. So in order to get a number or plus, it should invoke YYLex. Then your YYLex is reading your input and returning a token accordingly. So that is the reason. So you may draw a calling structure of the functions. So as you know, the main function will be invoked first. So your main function will call YY parse. Okay, as described here. Main function is calling your YY parse. Calling your YY parse. And YY parse needs YYLex. So for the token, so YYLex return token. Okay, so as you know, at this point, YY parse is requiring what is YYLex. So it is declared here. Okay, so sometimes it may invoke YY error for more from the input. Okay, so that is why this is declared here. And actual definition is provided here.
Thank you.
Okay.
Okay.
Okay, so do you have any other questions?
No.
No questions. Okay, good.
Yes.
So this is the end of today's lecture. And in the next lecture, you will just develop how to make a realistic parser using the Bison. Okay.
Okay.
Okay, good. So let's call it a day if you don't have any question. See you next time. Bye bye.